plus 5 equals times 9 times
3.
exactly. So this is y squared equals 27 minus 5, which is 22. Which method out of 4 methods that we know are applicable when solving quadratic equations? Which one in particular I will use now? Of course. And I will write y equals plus or minus the square root of 22. This is the algebraic solution. But then I will say only y equals the square root of 22. Is this clear? Okay. Make up a polynomial inequality. I'll start and you add whatever else you want. I'm going to say negative x. I'm going to say x plus 2. And give me 2 more.
X minus 3.
Awesome.
And x plus 5.
Awesome. Good. So this is a polynomial inequality. How do I solve this? What is the first step?
Oh, this is the graph that we made.
The chart. Excellent. I recommend the chart. The book presents a different method. However, I think that that method has some flaws because it will not tell you where to put the parenthesis or the bracket. And I know Nicole is an expert on this one. Yes. X is the variable in the problem. Now what will you say is the first row after that? Negative x.
Negative x, then x plus 2, x minus 3, x plus 5.
Indeed, because I have no more room. Awesome. Now what do we put in the chart at the top? Exactly, where each and every one of them is 0. I cannot stress enough, I would like you to redo all your tests. If you come for a review on Saturday for questions, I would like you between tomorrow and Saturday morning to redo all your tests. Okay, so when is this first factor 0? When x equals 0. When is this factor 0? When x is? When is this factor 0? And when is this factor 0? So now I have to be careful and put them in ascending order. And then I'm on my way to solve this. Negative 5 will be the first.
Negative 2.
Yes.
0.
Awesome. See, it only takes teamwork, a little bit on one problem, and then everything is much easier, right? Okay, so there is a 0 in each row. Where is the 0 for negative x? What is the 0 for x plus 2? And for x minus 3? And then for x plus 5? What will happen to the product if any of those factors is 0? Of course. And I have to do that. I have to write it. Now 3 of those have a positive leading coefficient or positive slope. They will look like this. They will come from negative, there will be 0, and then will be positive. But there is one that looks like this. Which one looks like this? Which means coming from positive, crossing the x-axis, and then going negative. Indeed. That's the only one. All the other ones follow the same pattern, the negative and positive. How many subintervals we have? Many. Let's count them. 1, 2, 3, 4, 5. In each subinterval, I count the negatives. I see 3 in the first subinterval. What will be the sign of the product in the first subinterval? Negative. 3 negatives will always give us a negative when we multiply them. In the next subinterval, I see 2 negatives. Positive. In the next subinterval, I see 1 negative. Negative. In the next subinterval, I see 2 negatives. And in the last one, I see negative. Okay? Now, only now, I look at this. Which sign is less than or equal to 0? And that's what I'm going to choose. Negative. Is the product ever negative? Oh, a lot. It's here, here, and here. But this is not the solution. The solution is for x. I'm looking for x that will make that happen. So then x in the interval, -5, with a bracket because there is an equal symbol, so I have to include -5. Union, union, that's it. Let's graph nonlinear linear inequalities, systems. Okay, so let's say 2x minus 3y less than or equal to 6. And let's say the other one is 3x plus 9 greater than or equal to 0. One of them has 2 variables, the other one has only 1. I'm asked to solve the system. How do I start? I write the equation 2x minus 3y equals 6. I'm not changing the inequality in an equation, but I need to write the equation so I can determine the 2 ordered pairs. So when x is 0, how much is y? When x is -2, very good. So the ordered pair is 0, -2. Now when y is 0, how much is x? So 3, 0. Good. Let's graph. Okay. So 0, -2 is right here. 3, 0 is right here. Do I draw a solid line?
Yes.
Good. So it's a solid line. So then I have 2x minus 3y less than or equal to 6. What do I do next? Because I only graphed a line, but this is not what I'm interested in.
You have to check in the point to see
Yes. Since it does not pass through the origin, I recommend work with the origin. So go back to the origin, 0, 0, 0 less than or equal to 6. True or false? True. So then I have to shade in all this. And this is 2x minus 3y less than or equal to 6. I'm done with the first one. What do I do with the second one? Yes, I have to write 3x plus 9 equals 0 first. And then x equals -3. Good. How do I graph the line x equals -3? What type of line is it? Vertical line. Awesome. Right here, -3. Do I draw it solid or dashed? Solid indeed. So I have x equals -3. Now I have to decide which direction to go. There is no need for a vertical line or a horizontal line to use a particular point. So when I solve this inequality, this says x greater than or equal to -3. Which direction do I go? To the right. Awesome. So this is x greater than or equal to -3. Now I have to intersect the blue with the red. Is there an overlap? Yes. This line, this vertex, this line, and everything in between. So both. Of course, if one of them is not solid, then I cannot include the points on that line. Okay. Any questions? Any questions? Let's graph a quadratic function. And also, I would like to look at a word problem from systems. To refresh your memory on that, chapter 4. At the end of chapter 4, trying to find a word problem. Uh, 38 on page 302. The Forest Theater can seat a total of 360 people. They take $15,150 when every seat is sold. If orchestra section tickets cost $45, that's where I like to sit, and balcony tickets cost $35, find the number of seats in the orchestra section and the number of seats in the balcony. Okay, so what do I write? How many variables we have here? 2 variables, which means that you are going to come up with how many equations? 2. Okay, so please give me 2 equations.
X plus y equals 350.
Awesome.
And 45x plus 35y equals 15,150.
Let's solve the system. You have 2 options. You either solve either for x or y and plug it in, or you decide to eliminate one of the variables and then you multiply the first equation by an appropriate number. It's up to you. So what would you like to do? Substitution or elimination? Okay, if we use elimination, we have to multiply the top one by whatever you want to eliminate, and it has to be opposite. Very good. This is what I would have done. Choose the smallest of the 2. Yes. Because it doesn't matter. I still have to multiply, right? So then I have negative 35x, negative 35y equals 360 times 35, and that is negative 12600. Awesome. 45x plus 35y, 15150. We indeed eliminated y. 45 minus 35 is 10x. And then 15, okay, minus what? 12600. I got 2550. So therefore, x, the number of orchestra seats, x is 255. If the total number is 360, then how much is y? And 360 minus 255 is 105. So therefore, our claim is 255, comma 105. Is it true? I don't know. What do I have to do now?
Plug in the x plus y.
Of course. This is definitely 360. I know 255 plus 105 is 360, but I don't know if this works. So 45 multiplied by 255 plus 35 multiplied by 105. And if the answer is not 15150, I have to start from scratch. But I checked in both equations and it works. Let's look at a couple of exponential and log equations. So let's say if I want to determine log base 3 of 27, I will say, I have no idea what this is. But I know something extremely important, most important concept in chapter 12, that every log equation can be replaced by an exponential equation. So what do I write? Raised to y equals 27. And I know how to solve this. Both sides have to have the same base. So I have 3 to the y power. And how do I replace 27? Indeed. Therefore, I know the answer now. Y must equal 3. What if I'm given this equation? Is this true? 3 to the third is 27. Now I want to change this into a log equation. Here's how I do it. I get some prep done first. Log, and try to figure out what I need to fill in and where. When I change this into an exponential, I start here. So then this is the base. What is the base then? 3. Then I say 3 raised to this number. What is that number then? And here I have to have 27. Very good. What if I'm asked to find log base 7 of 1? I'll say I have no clue. But I know what to do. What could y be? What number do I raise 7 to get 1? 0. There is no other number. Very good. What if I'm asked to find log of 3? Even if I write in this case something like this, what is the base here? I don't see a base. 10. 10 to y equals 3. I don't know how to solve this. But this is a log that I have in the calculator. So I will put it in right here, log. Here's my log of 3. Close the parenthesis. and I press enter. So I got 0.477. Are we okay with changing, for example, we did a lot of examples like this, like 4 to 2x minus 1 equals 8 to x plus 2. How do I solve such an equation?
You need to change them so they're the same base.
Right. So the left-hand side, prime numbers, and the right-hand side, 2 and everything to 2x minus 1. And this is 2 to the 2x plus 2. Copy the base. What happens with the exponents? 4x minus 2. Copy the base. What happens with the exponents? 3x plus 6. Now, I'm not canceling, I'm not simplifying. I'm saying two numbers are equal and they have the same base. What has to happen for this to exist or have a solution? You will have a solution only if 4x minus 2 equals 3x plus 6. This is linear. I move 3x and I move 2. Let's look at a word problem from quadratics. We did them all, but I'd like to go back. That's chapter 11 with quadratic functions. Okay, let's say methane is a gas, 88 on page 704. Methane is a gas produced by landfills, natural gas systems, and coal mining, and contributes to the greenhouse effect and global warming. Projected methane emissions in the United States can be modeled by a quadratic function. Look at that. Plus 1.93x and plus 173.9. Where f of x is the amount of methane produced in million metric tons. So that's the air we breathe. And x is the number of years after 2000, which means x equals 0 represents the year 2000. According to this model, what will U.S. emissions of methane be in 2018? Part B. Will this function have a max or a min? In what year will methane, that's part C. In what year will methane emissions in the United States be at its max or min? When? Max or min? So the first thing I have to do is I cannot plug in a name of a year. That's why I'm told x equals 0 represents 2000. So I can only plug in x equals 18. So it's 18 years from 2000, so then x is 18. And we know how to do that, right? So we just plug in, find f of 18, and I know you're going to have no problem with that, correct? Okay, what about, is this function going to have a max or a min? Or does it have a max or a min? The leading coefficient tells us. The leading coefficient is negative. Maximum indeed. How do I find the maximum? Exactly, the quadratic formula. If you remember the quadratic formula, you will always be able to remember the x coordinate of the vertex. Negative b is 1.93 over 2 times a. Negative 2 multiplied by 0.072. So disregard the negatives because we have two negatives. So then I have 1.93 divided by, in parentheses, the denominator, 2 multiplied by 0.072, and I get 13.4. 13.4. What does 13.4 mean?
Years after 2000.
Exactly, awesome. 2013 will be the maximum. Fine. But now if I'm asking you find the maximum, how will you find the maximum? Remember, this is the vertex. So this is 13.4. How do I find the maximum? Exactly. The maximum will be whatever I get for this. Indeed. Plug it in the function, and that's what it is. Are we going to have difficulties with graphing a parabola? The vertex, the axis of symmetry, the x and y intercepts? No. Okay. I want to look at a problem from chapter 2. These problems we looked at some time ago. I think they were in chapter 2. When we review the formulas, and I think it was in chapter 2. Okay, I'm going to make one up. Okay. Let's suppose that this is a tree. Don't ask me to draw it. I can't. And this is what really happens on the on site. So here's a surveyor. I cannot draw a person either. Okay. So he is, let's say, 20 feet away from this tree. And he's looking at the top of this little tree, and he realizes that if he looks up, then he sees both tops of the trees. He would really like to determine the height of the big tree. And he's able to measure this one. This is a tiny one. And he's able to measure it. Let's say he is 5 feet tall. And let's say this little tree is 15. Somehow he manages to measure that. But he would really like to, and he cannot. This is too tall. So he cannot measure this one. Okay? So you notice that there is a right triangle here, this one, in which I know this height because this is 15 and this is 5, so this must be 10. Let's also say that we know the distance between him and, let's say this is 100. And he can measure this on the ground, easy. So this is 10, this is 20, and then this whole thing is 100. And he wants to determine this. Well, of course, this will be x minus 5 because this is still 5, this is still 5, all the way. And this is a concept of similar triangles. This small triangle does not equal the big triangle. It does not. But they are similar. Because I can show that they have these two angles the same, this angle the same, therefore these two must be the same. So what is this important? Well, because if I know that they are similar, I can write proportions with their sides. So I start with this common angle. The opposite side, 10. In the small triangle. The opposite side in the big triangle, x minus 5. I continue with this angle. The opposite side, 20. I continue with this one. The opposite side, 100. I don't need the last one, which would have been for this, but I don't have this measure, and I don't have this measure. So I don't need the third one. And from here, what type of equation is this? It has a very special name. It's called proportion, right? What do we do in a proportion and only in a proportion? Right. So then 1,000 equals 20x minus 100. I add 100 and divide by 20 to get x. So the height of the tall tree, the whole thing, is 55 feet. Any questions? Please review chapter 10 a little bit on how to deal with multiplying and raising to a power and square root or the cube root over the cube root and so on and so forth.